Good morning, students. Today we are going to new topic, that is null points or neutral points in magnetism concept. See, at null points what will happen means there is no resultant magnetic induction at a point, okay, in a given magnetic fields. In a given magnetic field at one point, okay, magnetic induction resultant is becomes zero, means that points only we are calling as null points or neutral points. See students, here we are observing the statement here. The points in the magnetic field where the resultant magnetic induction becomes zero are called null points or neutral points. We may call like that. See students, for getting an idea about these null points, few cases we want to discuss here. So one by one we will discuss here those things. Okay. Case 1 we will discuss now. See students, here the thing is, when a magnet is placed in the magnetic meridian with its north pole facing geographic north, the combined magnetic field lines due to earth and bar magnet are shown in the figure like this we are representing. You know one thing students, earth is always acts as a one magnet. Okay, in that condition we know very well magnetic field lines are coming from south to north, but in case of bar magnet, magnetic field lines are coming from north to south. So here the condition is given like this. Here this is, once observe carefully, geographical north is present, this one is geographical south is present. Actually this is geographical east and west, like this we are mentioning. See, this is one bar magnet student. Towards geographical north we are placing here magnet north pole. So geographical south direction we are placing here magnet south pole direction. So how we are observing here null points in this situation means, this is one null point we are observing and this is another null point is observing here. This null point we are placing here n1 name, here n2 name. Finally we are observing these two null points are present on which line of this bar magnet? Equatorial line of this bar magnet. So first of all, how these lines are magnetic field lines coming here, by observing diagram once you will get one clarity. Okay, in case of magnet, compulsory magnetic field line starts from north and then goes towards south continuously like this. Here, okay, diverging from north and converging from south or converging towards south we are observing here. So in this situation null points compulsory we are getting on equatorial line of the bar magnet. See students, here n1 is present, here n2 is present, between these two some distance is present, but I am observing here one average distance between n1 and n2 from the center of this magnet is I am taking as a small d. See, ultimately in this situation in general, this is midpoint like this acting. This center of the magnet is acts as a midpoint. So here to this side or here to this side, averagely we are taking the distance is small d, like that we can able to choose them. Okay students. See students, here clearly mentioned here at n1 and n2 on the equatorial line, the magnetic induction field due to magnet is exactly same as Earth's horizontal component. The points are called null points. So if the average distance of n1 and n2 from the center of the magnet is were taken as d. So here what the thing will be happen, B magnet value is equal to BH. BH is nothing but here horizontal component of Earth's magnetic field. What is the thing? Horizontal component of Earth's magnetic field, like this you will get it. So students, here BH value is equal to mu naught by 4 pi into m divided by d square plus l square whole power 3 by 2. This is generally on equatorial line magnetic induction value. Okay, but if suppose if you are going for a short magnet or a small magnet we are taken, means this d square plus l square whole power 3 by 2 is approximately we are taken as a d cube, since reason is d is very greater than l. Therefore BH value is equal to here mu naught by 4 pi into capital M divided by d cube, like this one equation we will get it. Okay students, these values are very important for solving problems in objective exams only. Okay, on this concept we are unable to frame questions in PU level. Okay students, so few more cases also now we will discuss. Clearly you will observe. This is one more case, students. North pole of the magnet pointing towards geographical south. So once observe carefully, this is geographical north and this one is geographical south, but this is the magnet south pole and this one is magnet north pole. So here facing south pole of the magnet towards the geographical north and north pole of the magnet is facing towards the geographical south. Like this we are arranging. In this situation, we know very well magnetic field lines always going from north pole to south pole of the magnet continuously like this. So here also from this diagram roughly I am mentioning here, this is one null point and this is another null point we are observing. Those two null points are lies on the axial line of the magnet. On which line here present? On axial line of the magnet is present. So here from the center of the magnet, average distance between n1 and n2 we are taken as small d only. Is it clear, students? So average distance between n1 and n2 from the center of the magnet is we are taken as a small d. Like this we will represent it. So students, here B magnet value is equal to BH we will get. This is axial line. So axial line condition we know very well. Magnetic induction on axial line value is B is equal to mu naught by 4 pi into 2md divided by d square minus L square whole square is the general condition. For a short magnets, we know d value is greater than L, therefore d square minus L square whole square is approximately we are taken as d power 4, students. On simplification, b value is equal to mu naught by 4 pi into 2md divided by d power 4, therefore b value is equal to mu naught by 4 pi into 2m divided by d cube. Like this we can get one relation. Okay, till now just we are appears as magnetic inductions on equatorial lines and magnetic inductions on axial lines conditions we are observing. So now we are going for different concepts related to null points only. Now this concept is, students, neutral points in the combined field due to isolated magnetic poles. Due to isolated magnetic poles, now we want to calculate here null points. So once observe this diagram, students, this is one pole strength m1 is present, this is another pole strength m2 is present. These two are separated by distance d. For example, here clearly mentioned m1 is less than m2. m1 is less than m2 means okay, here two like poles are separated. So this is north pole first one, here north pole second one. Two like poles having pole strengths m1 and m2 are separated by distance d. In this situation, what the thing will happen? Null point is lies between those two poles only. Let here at a small n point null point is existing. So I am imagine here m1 is less, so nearer to the less pole strength at a distance x null point is exist, like that I am imagining. Okay, students, then here what will happen at null points? Okay, equal magnetic inductions will be present, so therefore we can represent like this as b1 value is equal to b2. So by general statement for magnetic inductions, we know mu naught by 4 pi here to this point means m1 divided by x square. Similarly here mu naught by 4 pi m2 here to here distance how much is present, students? D minus x is present, so this is d minus x whole square we are taken. So here mu naught by 4 pi and mu naught by 4 pi will be cancelled. Okay, on simplification, finally we will get here x value is equal to small d divided by root over m2 by m1 plus 1. Like this one equation we are observing. What is the relation we are finding here? X value is equal to d divided by root over m2 by m1 plus 1. This is similarly as between charges already in electrostatics known. In that condition also x value is equal to d divided by root over q2 by q1 plus or minus 1. Previously we have some knowledge. In the same manner, this null points also we can substitute. Is it clear, students? Then one more case. Till now like poles are separated by distance we are discussed. Then in next case unlike poles are separated by a distance. Now we will discuss it. Okay, students. So in this case, students, when two unlike magnetic pole strengths M1 and M2, here M1 is clearly we are taken as less than M2, are separated by distance d at a distance x outside nearer to the less pole strength, null point exists like that mentioning. See here, this is one north pole we are taken, this is another one south pole. These two are separated by distance d. Here pole strength M1 is present, here M2 is present. Clearly in starting only we are mentioning, students, M1 is less than M2. So nearer to this M1 only, outside of this one null point existed at a point small n. Okay, so here M1 to here this distance is maintained as a small x. Some M2 to here how much distance is observed means d plus x distance we may observe like this. So in this condition also what will happen, students, at null point b1 value is becomes equal to b2 only. So therefore on simplifications here we are getting as b1 is equal to b2. Therefore mu naught by 4 pi into m1 by x square is equal to mu naught by 4 pi into m2 divided by d plus x whole square. So just observe carefully, students. Therefore x value is equal to, we will get small d divided by root over m2 by m1 minus 1 we are getting. So unlike poles are present means here minus 1 we are taken. If suppose like poles are separated by distance d means here plus sign we are choosing. Is it clear, students? In this way easily we can get the null point positions. Till now, students, we are discussed by the concept of pole strength. If suppose instead of pole strength, if suppose we are taken magnetic moments, so how we will get a null points concept means. See, first of all you can take two magnets, students. First magnet having magnetic moment m1 and second one having magnetic moment capital M2. So here also one thing I am mentioning, magnetic moment m1 is less than m2 I am choosing here. So here one diagram clearly mentioning, students, this is first magnet, this is first magnet north pole n1, this is the second magnet, this is the second magnet north pole n2. Okay, these two are separated like this, but from the center of these magnets how much distance is present means okay, d distance we are maintained. First magnet magnetic moment m1 is replaced here, here m2 is represented here. So if suppose in this condition null point is exist in between these two magnets, so here at a small n null point I am representing. This small n is maintains the distance x from the center of the first magnet, that is we are taken as x. So here to second one we are taken as d minus x only. Like this we may represent it. See, students, this is the common axis for both the magnets, and common axis present means here it is present means okay, this null point is exist on axial line of first magnet and this small n is lays on the axial line of the second magnet also. So here axial line concepts we are remembering. Which concepts we are remembering? Axial line concepts we are remembering. Here also b1 is equal to b2. Once remember, on axial line what is the magnetic induction formula? Mu naught by 4 pi into 2m divided by d cube for short magnets. So we are remembering that formula means here mu naught by 4 pi into 2m1 divided by x cube value is becomes equal to mu naught by 4 pi into 2m2 divided by d minus x whole cube. Okay, like this we can get it, students. So on simplifications mu naught by 4 pi and mu naught by 4 pi will be cancelled both sides. Then finally x value is equal to d divided by 1 plus m2 by m1 whole power 1 by 3, or x value is equal to, we can represent d divided by here m2 by m1 whole power 1 by 3 plus 1 also we can able to write. Here in which conditions like poles facing each other, in this situation we are represented. So next further one we are ready to discussing about unlike poles, okay, facing each other. One more case we will discussing now. Okay, students, this is the last case, students. Unlike poles are facing each other means, observe carefully, this is first magnet south pole, this is the second magnet north pole. This magnetic moment is m1 is present, here m2 is present. So actually this is the equatorial line for both the things. Maybe this is the center of the first one and this is the second center. So here this is equatorial line for both the things, we people know. Let here neutral point is maintained from first one onwards. Here x distance is present, here from second one to here d plus x is present. So in case of equatorial line, we people know mu naught by 4 pi into m divided by d cube is the general formula. Here based on the situation, here mu naught by 4 pi into m1 divided by x cube value is equal to mu naught by 4 pi into m2 divided by d plus x whole cube. So on simplifications here, null point is we are getting at a distance x is equal to d divided by m2 by m1 whole power 1 by 3 minus 1. So x value is equal to d divided by m2 by m1 whole power 1 by 3 minus 1, like this we are getting. So students, based on this same concept, in next coming class I am able to solve few problems. Okay, be ready for that. Okay students, thank you.